Alright, let's have a look at this thing called change in momentum. Have a look at here. Change in momentum. Let me just bracket that bit off, right? And then something else called impulse. It's surprisingly easy. Alright, so let's watch by means of an example. Alright, we've got a 2 kg trolley. Let's give it a velocity of 3 meters per second. But I'm going to call this an initial velocity. So this trolley now is accelerated. It has a new velocity. So we call the final velocity 7 meters per second. So there's a change there. Now this initial momentum, remember that momentum is mass times velocity, so 2 times 3 is going to be 6. I'm not going to put units now, right? And then the final one, in a similar manner, 2 times 7 is going to be 14. So we got these two different momentum values. So I'm just going to look at that. The difference in the two, it's called change in momentum, and the symbol is delta P, change in momentum. Right, so that's obviously equal to the final momentum, subtract the initial one. That's going to be 14 minus 6, and that gives us a delta P, or change in momentum, of 8, let's put the units now, kilograms meters per second. So let's just write this part down, right, that delta P really is. It means change in momentum. E-N-T-U-M. Right, that's that whole thing, the change in momentum. It's also known as impulse. Same thing. All right. Now, anyways, let's look at this from a different perspective altogether. Now, we know that delta P really means you're subtracting the two momentum values. But we know that this PF here, P final, is really that one. And this is this one. Okay, mass times final velocity and minus mass times initial velocity. So in the data sheet, it's given like this. Okay, but I personally believe we should take out that m as a common factor and do it like this. This is very convenient when you're trying to solve stuff, okay? Very, very convenient. So what's what I mean? Same example, okay? Delta P, so write the mass just once, 2, and you subtract the velocities, that is 7 and 3. So we get 7 minus 3, and so we say the change in momentum is 2 into 7 minus 3. That 7 minus 3 is 4 times 2. You get 8 kilograms meters per second. Now this setup is very, very convenient. You'll see this in many of the more involved questions. It is really convenient to solve using that method.